Okay, let's look at a linear regression for our curve fitting or modeling. So in this case, first thing we need to do is copy down our calculator directions, which are identified at the top here. You'll notice the first three, you do those only once. First time use the calculator, and then this we're going to do for every single problem. So those are the main steps that we're going to do, and then we have some troubleshooting. So if you don't have those, you will want to make sure you do. If you did your foldable in class, then you should have those already. So the first thing you have to do is make sure your diagnostic is on, and then also make sure when you go into your stat menu that you have all the correct columns. Okay? So I'm going to look right here at this wonderful graph. Notice we've got the data and we've got a graph of the data. Now the graph is shown as a scatter plot, and if I look at the scatter plot and look at the curve that it's making, you'll notice it does actually look linear. Okay? It's not super strong, but it is strong, and it has a negative correlation. So under correlation, I would expect to see strong and negative. Okay? Now something else that we need to know about the data is that the first line is my L1 values, which is also my domain, or my x's. And the second line is my L2 values that I'm going to enter into the calculator. Those correspond to the range. Okay, so now we have all these beautiful numbers that we are going to take time to plug into our calculator. So we're going to go to the stat menu. We're going to hit the edit function so that we can enter all these beautiful data into our calculator. Now something I'd like you to notice about this data is you have repeats in the x values. So these x's don't go in order from least to greatest, and we have some repeats in the y values. 67 and 67 repeat. Lots of numbers close together in the 50s. That means we're going to have a linear regression. Anytime there's a repeat value, you're going to have a linear. There's no way to do any other kind of regression for it. So once you get all that data entered in, and you have to make sure you have the same number of entries in the L1 column as you do the L2 column. Otherwise, the calculator will not work. Okay? We're going to quit out of that and then go back to stat. Now we're going to go over to calculate. So we hit our right arrow function, go over to calculate, and you'll notice the number 4 is lin reg. That means linear regression. So I'm going to hit enter for linear regression. Now if you have a newer calculator, it'll go through this list. Otherwise, it'll just ask you if you really want to do this. And we're going to hit calculate. And then it shows us this beautiful information. Now down at the very, very bottom, notice the R value. The R value is negative 0.97. Okay, so R equals negative 0.97. That is the correlation coefficient. That means 97% of the data is actually on this particular line. Now we need to figure out the equation. I'm going to scoot my calculator over here so I can actually write this down. So they told us it's y equals ax plus b. And then a is a negative 0.31, and it keeps going. We're only going to take it to 2 places after the decimal. I'm going to write my equation right down here because I have big handwriting. So I have y equals negative 0.32, because I rounded that number, x. And then b is 77.73 plus 77.73. Okay? Now it asks which one is the slope. Okay, well, if it's y equals mx plus b, the slope is always with the x. So my slope is negative 0.32. Good to know. So it's negative. It's downhill. We expected that. Okay. Now they want to know what is y when x is 55. Well, if you look up at your data, we don't have a 55 anywhere in here. So we're actually going to have to plug that in. So I want to know what y is when x is 55. Now there's two ways to do this. We could go in the calculator, plug the equation into y equals and look at the table, or we can just go back to the main screen and do negative 0.32 times 55 plus 77.73. Now we hit enter. Now we have a prediction, and this is how the data is used in the real world. We take what we already know from live data that we have gathered, and we're going to predict what the value would be somewhere else. Well, does this make sense? Okay, let's pick an x that's close to 55. I notice I got a 59 right here. Okay, well 59 is at 61. 55, y is at 60. So that sounds reasonable. Okay, I didn't get something like 507. So please check to make sure your data is reasonable.